All right, today we've got a really cool scientific mystery for you. It's a story that has it all: hidden treasure, a map that's basically useless, and an AI detective that finds clues nobody else could see. Okay, so picture this. Deep, deep underground, there's this super hot water, right? Geothermal brine. And it's basically a liquid treasure chest full of all these valuable minerals, the kind of stuff we need for all our modern tech. The only problem? Actually getting to that treasure. And here's the kicker. The map to this treasure, the scientific data, it's a complete mess. I mean, it's sparse, it's got huge chunks missing. It's like someone gave you a treasure map that's been through the wash and then torn up. So how on earth are you supposed to find anything with that? So that's our starting point. We're going to look at this huge challenge: how scientists can possibly predict where to find these super rare elements when the data they're working with is just, well, terrible. The core of the problem, really, is what's called imbalanced data. It's the classic needle in a haystack problem, but on a massive scale. You're trying to find one specific thing, let's say a valuable element like vanadium, but it's buried in this enormous haystack of really common stuff like chlorine. All that common stuff just drowns out the signal from the thing you actually care about. And this chart, wow, it really drives the point home. Just look at this. You've got chlorine over here at, what, over 70,000 parts per million? Then way, way down here, you can barely even see it, is vanadium at 0.002. I mean, the difference is just staggering. It's not even on the same planet. So you have to ask yourself, how is any AI supposed to learn anything useful when the data is this lopsided? Okay, so with a puzzle this tough, you need a special kind of investigator, and that's exactly what the researchers brought in. They hired an AI detective, specifically a deep neural network. So what the heck is a deep neural network, or a DNN? You can think of it like an AI with a multi-layered brain. Each layer digs deeper, finding these super complex patterns in the data that a human could just never spot. It's pretty much the perfect tool for a job like this, for finding those hidden connections and all that mess. But, even our super smart AI detective has a weakness, a real Achilles heel. The researchers pointed out themselves in the paper. You feed this thing a small or lopsided dataset, and it just gets confused. It can't tell what's a real pattern and what's just noise. Its predictions become totally unreliable. And that is the big problem it has to solve. So, what do? How do you help your AI see clearly? Well, the scientists gave it a secret weapon. Or more like a whole superpowered toolkit filled with some seriously clever tricks. First up in the toolkit, they didn't just train one AI. No, they trained an entire army, literally 1,000 different AI models, all tackling the exact same problem. And you might be asking, why 1,000? Isn't that overkill? Well, think about it. Any single AI might just get lucky and give you a good answer by chance, or an unlucky one. By using this whole army of AIs, the researchers could basically see the consensus. It gives them a much, much more reliable idea of what's really going on and how certain they can be about the results. Okay, the next tool is just brilliant. It's this technique called SMOGIN, which is basically a smart data stretcher. It's a simple three-step process. First, it zeroes in on those rare data points, our needles. Then, and this is the clever part, it creates new, totally fake but realistic data points right next to them. And just like that, you've built a much more balanced data set. You're giving the AI more of the rare stuff to look at so it can actually learn. And the last tool in the kit, it's kind of like giving the AI a pair of magic glasses. They use these transformations. A popular one is called Yo-Johnson, that essentially unskews the data. I mean, look at the before and after here. You go from this chaotic, lopsided mess to something that's way more even and balanced. It just makes it so much easier for the AI to see what's actually going on. All right, so now our AI detective is fully kitted out. It's got its army of clones, its data stretcher, its magic glasses. It can finally see the data clearly. And that's when it happened. It found a clue. A really surprising clue that nobody saw coming. First, let's just remember how bad things were. This is the before shot. Without the toolkit, the AI was just awful at this. I mean, look at the scores for vanadium and copper. They're terrible. The model was basically just flipping a coin, totally guessing. And now, check out the after. Boom! With the toolkit, the accuracy just goes through the roof. The score for vanadium jumps from practically nothing up to 0.55.
Copper nearly doubles. It's a night and day difference. The AI isn't guessing anymore. It can actually do its job. But here's the thing. Getting better predictions was great, but it wasn't even the most important discovery. While our AI was digging through all that data, it found something else, a hidden clue, a connection that showed one particular element was way, way more important than anyone thought. And here it is, the big reveal. This chart shows us which elements had the biggest influence on the AI's predictions. And just look at lithium. It's off the charts. It's not even close. It wasn't iron, it wasn't magnesium, the things you might expect. Nope, it was lithium. Lithium was the key all along. Now, this is what makes it so smart. If you just looked at the raw data, yeah, iron and magnesium would seem important. But our AI detective was clever enough to realize that they were basically saying the same thing over and over. Their information was redundant. But lithium was telling a unique story. It had a powerful signal that nothing else did. It was the master key. So this is more than just a cool AI finding. This has some huge, real-world consequences for how we actually do science. So what's the big takeaway here? Well, for one, it means we can revisit all these old, messy datasets we thought were useless and actually find new things. It means when we plan new experiments, we can be way smarter and cheaper about it. Just focus on measuring lithium, for example. And all of this could seriously cut down on research time and cost, and maybe, just maybe, make this whole idea of mining minerals from geothermal water actually happen. The researchers themselves say it best. These findings can be a guide for the future. You don't have to go out and measure everything anymore, which costs a ton of time and money. Now you can optimize your work to focus only on the features that actually make a difference. And maybe the biggest deal of all is this. It changes the AI from being a black box, where you put data in and an answer comes out, but you have no idea why, into a glass box. We can actually look inside and understand why it's making its predictions. And that's how you turn raw AI power into real, useful human knowledge. So there you have it, a superpowered AI detective, digging through messy data to find hidden treasure. It's incredible, and it really makes you think, if it can solve this mystery, what other huge scientific puzzles out there, in medicine or space or climate change, are just sitting there waiting for the right AI detective to come along and crack the case?